Good morning all. So in today's class we'll look at one more problem on finding the Frobenius series solution. So you are given the equation 4x square y double dash minus 8x square y dash plus 4x square plus 1y equal to 0. So it is given that it has only one Frobenius series solution, so we need to find that solution. So first of all, let us put it in the standard form: y double dash plus p of x y dash plus q of x y equal to 0. So p will be minus 2 and q will be 1 plus 1 by 4 x square. അപ്പോൾ xpx എടുക്കുമ്പോൾ xpx minus 2x വരും. x square qx is x square into 1 plus 1 by 4 x square. So here when you this is in as polynomial, so x square q of x square plus 1 by 4 varum, xp of x minus 2x. So here p naught will be, there is no constant coefficient here, but p naught will be equal to 0 and q naught 1 by 4 varum. So therefore the initial equation will be m into m minus 1 plus p naught m plus q naught. For p naught in the term 0 ആണ്. So you will have m into m minus 1 plus 1 by 4. So that is m square minus m plus 1 by 4 equal to 0. So this is m minus 1 by 2 whole square. So the roots are going to be equal roots. So both roots will be equal to 1 by 2. So you have m in the form, so m is equal to 1 by 2. So therefore our solution is of the form y equal to x raised to 1 by 2 into summation n equal to 0 to infinity a n x bar n. So taking x power 1 by 2 inside, we will get summation n equal to 0 to infinity a n x raised to n plus 1 by 2 varum. Taking the derivative, so we need to find y dash and y double dash. Y dash will be summation n equal to 0 to infinity n plus 1 by 2 into a n x raised to n minus 1 by 2 varum. Y double dash summation n equal to 0 to infinity n plus 1 by 2 into n minus 1 by 2 a n x raised to n minus 3 by 2 varum. Now let us substitute the derivatives into the equation. So we will get 4x square y double dash substitute minus 8x square y dash plus last term is 4x square plus 1 into y. 4x square into summation n equal to 0 to infinity a n x raised to n plus 1 by 2. Then last term is summation n equal to 0 to infinity a n x raised to n plus 1 by 2. Let us make all the coefficients to be x raised to n plus 1 by 2, and when you change that നമുക്ക് summation 2 to infinity ലായിരിക്കും start ചെയ്യുക. അപ്പോൾ എല്ലാ സമ്മേഷനും 2 to infinity കൊണ്ട് start ചെയ്യുക. So let us first make the powers to be x raised to n plus 1 by 2. അപ്പോൾ ആദ്യത്തെ ടേമിൽ x raised to n plus 1 by 2 ആണ്. അപ്പോൾ ഈ ലെഫ്റ്റ് സൈഡിൽ നമ്മൾ എക്സ്ട്രാ ടേംസ് ഉണ്ടെങ്കിൽ 2 to infinity സ്റ്റാർട്ട് ചെയ്യണമെങ്കിൽ എക്സ്ട്രാ ടേംസ് വരും, അത് റൈറ്റ് സൈഡിലേക്ക് കൊണ്ടുപോകാം. സോ ഫസ്റ്റ് ടേം x raised to n plus 1 by 2 ആണ്. സെക്കൻഡ് ടേം okay, so you have we need x raised to n plus 1 by 2. So start n from 1 to infinity. So n will be replaced by n minus 1. So second series is summation n equal to 1 to infinity 8 a n minus 1 n minus 1 by 2 varum x raised to, this will become n plus 1 by 2. And here also start from 2 to infinity. 2 to infinity start ചെയ്യുമ്പോൾ 4 a n minus 2 varum. This will become x raised to n plus 1 by 2. And in the last term you have x raised to n plus 1 by 2. അപ്പം ഇവിടെ മാത്രം 2 കൊണ്ട് സ്റ്റാർട്ട് ചെയ്യും, ബാക്കി 0ലും 1ലും ആയിരിക്കും സ്റ്റാർട്ട് ചെയ്യുന്നത്. അപ്പോൾ ആ എക്സ്ട്രാ ടേംസ് റൈറ്റ് സൈഡിലേക്ക് കൊണ്ടുപോകാം. ഓക്കെ, സോ when you take okay, so now we'll start this from 2 to infinity. Appa n equal to 0 varumbo 4 into 1 by 2 into minus 1 by 2 a naught x raised to 1 by 2. So that I have taken to the right side, and n equal to 1 varumbo 4 into 3 by 2 into 1 by 2 a1 x raised to 3 by 2. So that is the second term here. Then here n equal to 1 in the term right side like 8 a naught into 1 by 2 x raised to 3 by 2. So right side like plus out. Then here it will remain the same, and for the last sum, summation n equal to 0 to infinity a n x raised to n plus 1 by 2. 0 and 1 term right like go. So that is a naught x raised to 1 by 2 and minus a1 x raised to 3 by 2. Okay, and now simplify this. So simplify cheyumbo a naught x raised to 1 by 2 will cancel off. So on the right side you will get 4 a naught minus a1 x raised to 3 by 2, and on the left side, so this is a simplified form. So 4n square an minus 8 n minus 4 an minus 1 plus 4 an minus 2 x raised to n plus 1 by 2. Now let us equate the coefficients on both sides. So here 2 തടങ്ങിയാണ് സ്റ്റാർട്ട് ചെയ്യുന്നത്. അപ്പോൾ 5 by 2 വരും. So x raised to 3 by 2 in a coefficient equate ചെയ്യുമ്പോൾ that will be 0. So that will give a naught equal to a1. And now this coefficient will be x raised to n plus 1 by 2 in the coefficient 0 ആയിരിക്കും എല്ലാ n value. So equating this to 0, so you will get an equal to, so an will be obtained in terms of an minus 1 and an minus 2. So you will get 8n minus 4 an minus 1 minus 4 an minus 2 by 4n square. So 4 will cancel off. So remaining you will get 2n minus 1 an minus 1 minus an minus 2 by n square. Now we have a naught equal to a1. So ഇവിടുന്ന് a2 ന്റെ value കിട്ടും. So a2 will be, so when you substitute here n equal to 2, you will get 2 a naught by 4. So that is a naught by 2 factorial. At the a3, substitute ചെയ്യുമ്പോൾ you will get 5 a naught by 2 minus a naught by 9. So that is a naught by 3 factorial. A4 will be 7 a3 minus a2 by 16. So that will be a naught by 24. So that is a naught by 4 factorial വരും. അതുപോലെ a5 എടുക്കുമ്പോൾ you will get 9a4 minus a3 by 25. So upon simplifying, you will get a naught by 5 factorial. So that is the required coefficient. So therefore, y1 is x bar 1 by 2 into 1 plus x by 1 factorial, x square by 2 factorial plus x cube by 3 factorial plus etc. So this is a series for e raised to x. So you will get the solution to be x raised to 1 by 2 e raised to x. So since there is only one root for the initial equation, there is only one Frobenius series solution.